Good morning, everybody. Thanks for being here. My name is Adib Saikali. I'm part of the Pivotal Platform Architecture team. That means my job is to spend a lot of time working with customers like yourselves, kind of helping them navigate their path to the cloud-native journey. Just as a matter of curiosity, who here is using PCF? If you can raise your hand. Yay, good, awesome. You've come to the right spot for this talk. So the main purpose of this talk is to kind of, you want to build cloud-native secure applications. So I assume that that's why you're actually here today. And the challenge is a bit like this. You reach into the security toolbox, and it's a little bit confusing. Who feels like this when they're talking to security people? All right, if you're feeling like this when you're thinking about security, you've come to the right talk, okay? And unfortunate reality of things kind of being not disorganized. The tools are good. If you look at this toolbox, the tools are great. All of the tools there look like they're in good condition. There's just a lot of them, and it's really easy to use the wrong tool for the job. And it's easy to get confused about how to use the tools. So the goal of today is kind of like this. We're going to take these tools, we're going to organize them nicely into your toolbox so you know which tool to reach for. So the goal today is not to go deep on exactly the super details of how these tools work. It is more to understand how the big picture comes together. And so that's going to enable us to do two things. One is it'll help you on your journey to building secure cloud-native applications. And the far more important goal is to make it so that you can work better with your InfoSec team. How many folks here are actually just developers? Raise your hand if you're a developer. Anybody here an InfoSec professional? I don't see any hands up. Great. So you guys have come to the right place. How many people kind of have this kind of relationship with their InfoSec team versus the one with boxing gloves? Who's got the boxing glove relationship? Raise your hand. Yeah, that's kind of most people, most customers I talk to. There's a lot of kind of back and forth, and the InfoSec people don't want us to be productive and all this other type of stuff. So we'd like this kind of harmonious relationship to exist between the devs and the InfoSec team. And I think if you were in the opening keynote this morning with the security panel, I believe one of the folks there was like, I'd like developers to be more curious about security and ask what could go wrong. So that's the purpose of today. So the plan is to explore security patterns and protocols kind of through a series of use cases and pointers on how to implement them with PCF and Spring. So again, I'm not going to get into the details of how to use Spring Security 5 OAuth. That was a great session about that yesterday. You can watch the replay if you missed it. The goal is to more see how all this stuff comes together. So if this is not what you're looking for, if you were looking for the deep dive on stuff, now is a good time to go to your backup session that you would have gone to. If you're here to kind of get the big picture, welcome. Thank you for being here. So let's start from the very beginning. So let's say you have, you've just built a web app, and this application is, traditional web app. You have an application server, and then you have a database, and you have a login form. This is kind of what a lot of early web apps looked like, and the application is going to take the username and password, and it's going to validate those username and password against the database. And you need to implement fun things in your application, like the user forgot their password, and the issue with it here is that every time, once you have this working, the rest of your application you're changing all the time, but the user functionality is tends to be fairly static. So that introduces risk, because when you change something in one part, the other parts could also break. This is generally very easy to implement with Spring Security. You just do like a user detail service and you're done. So I've done this in the past. I'm sure a lot of you have done that too. There are problems with this, and we're going to kind of build up towards what some of those problems are and get to eventually microservices and what's available for securing them. So your company grows, now you have two applications. So you're like, aha, what should I do? Should I replicate the functionality with login form to the other app? Because I don't want to like have everybody create two sets of accounts. So you're like, great, I know what to do. I'm going to extract my user tables out of my one database, and I'm going to put them in a new database. And this way, both applications can use Spring Security with a user detail service, and you can log into both of them. This kind of works, but there are some challenges with it. You have two applications that are collecting usernames and passwords, so you're one developer away from logging passwords to the log files, or some other bug in the application that does SQL injection and lets you pick up people's usernames and credentials and other things like that. You have duplicate code that's in application 1 and application 2. Authentication logic, again, it changes a lot less than the rest of your applications, so you have to kind of do a lot more regression testing to prove that things actually work. And so you need to do a lot of coordination between app 1 and app 2 whenever you're making releases with this approach. So what could you do? Well, life gets more complicated. Your company buys a third-party application, and you don't have the source code for this app, so you can't actually make it talk to your user tables. And so what can you do for this? So you do what a lot of people have done in the past. You're like, great, I'm not going to use my own user database. I'm going to introduce a directory server. So this is, enter, Q, Active Directory, open LDAP, something along those lines. And now what you're going to do is you're going to say, okay, my applications are still going to display the username and password screens, but I'm not going to store the credentials in my own database. I'm going to put the credentials and the user information in a directory server so that any application, whether I'm the one that's coding the application or it's an application that I've acquired, is going to be able to do the login. So this is probably widely deployed in the enterprise. Who has apps today that's doing this? Raise your hand. I'm surprised that not everybody's raised their hand. I guess not everybody's working for an enterprise. It's a big improvement over using the SQL database, our own table, and this is very easy to do with Spring Security LDAP. So if you have Spring Security LDAP, you can pull this in and you can do it. But you still have this bad thing going on, which is that your application is collecting credentials. And if it's collecting credentials, it can leak those credentials. And if those credentials get leaked, then bad things can happen. It also tends to be kind of optimized for username and password credentials. So if you want to do like two-factor authentication, that gets a little bit harder to do with the LDAP type approach. And it only works inside of one company's boundary. So we'd like something better. In fact, we'd like something where we don't have to trust our username and password to the application itself. So that brings us to, okay, great, how are we going to do this? Well, we're going to introduce a single sign-on authentication server. And what's going to happen is all the applications, the third-party application and application 1, application 2, they're all going to redirect the user login to the OpenID Connect server, for example. And there, it's going to collect the username and password or do multi-factor authentication, send you like an SMS message, and have you type that security code in. And it will maintain its own database of users. So this is great because the apps don't see credentials. It's very easy to implement with Spring Security. Like you really have 0 lines of code to do. You just have to put on some configurations and you're done. And is a big improvement over just doing LDAP. And it is very, very widely deployed. There's actually multiple generations of SSO that are out there. Some are based on Kerberos, some are based on SAML, and some are based on OpenID Connect. So I'm going to focus more on OpenID Connect today because that's kind of more the cloud-native way to do things as opposed to the older standards. So there's lots of products that do this, and the challenge is those products have lots of knobs, and they use lots of standards, and we're back to that toolbox image from the beginning where it's kind of hard to know how is this stuff actually configured. So time for our first demo. So what I've got here is 2 applications, and you're going to see how awesome my CSS skills are very shortly. We're going to start with, oh no, hold on. I'm going to do this and new incognito window. Okay, great. So I'm going to go to localhost 8080 first. And there is the Cloud Foundry login screen. This is the UAA, which is a component of Cloud Foundry. It's open source. It does implement the OpenID Connect protocol. And it's very much like used in everywhere in Cloud Foundry land. So I'm just leveraging it so I can have a free open source OpenID Connect server running on my laptop. Okay? So I have two applications. One application is running on localhost 8081. And if I go there, oh, hold on a second. It looks like I went nowhere. I actually did. I got redirected back to the login screen. So I'll do that again one more time so in case you missed it. So localhost 8081, done. All right, let's log in. Okay, that's it. So this is my banking portal, all right? I'm going to explain this token later. So I'm not going to explain what's there right now. We'll come back to it and we'll decode this token actually. So let's go to the other app, which is running on localhost 8082. Hold on a second. Did you guys notice that? I didn't see the login screen, right? I went straight to the application. And that's the value of using a technology like OpenID Connect. Now, in particular with OpenID Connect, the good news is it's widely deployed on the internet. So if you're doing things like login with Google, login with Facebook, login with Twitter, this is exactly the same process. And by the way, I welcome questions. Don't wait till the end, right? Ask questions anytime they pop up into your head. That's very welcome. So now that you guys see this, you'll see that, hey, the app itself does not actually collect the username and password. The Cloud Foundry UAA is doing that. When I go here, I can go to my account settings, and I can see what my account is. Now, you'll notice here something strange if you're somewhat familiar with this. Who's used to Google, when you log in with Google, asking you for permission? You're like, why didn't it ask for permission? Anybody wondering that? Nobody? It didn't ask for permission because when I configured it in my application here, I actually said that auto approve is equal to true. Yeah, absolutely. All right, how's that? Better? Actually, let me just make it a little bit bigger. Okay, so when I registered my applications with the OpenID Connect server, I said, please don't show the user, don't ask them for permission if they approve this. Why did I do that? Because in this case, I'm kind of deploying it if I was like the bank in quotes, right? And I had an application called Investment Portal and Banking Portal, and it popped up a little approval screen. Do you approve if the bank reads your own information? People are gonna think that they've been hacked in the wrong spot. So just understand that when you do that, you can configure the products you're using so that it doesn't ask for permission. And this would allow you to kind of have a nice user experience. If I did make it ask for permission, I'd be able to go here, I would see it, and I could revoke access to the applications that I've given access to. Okay? And that's one of the key things about OpenID Connect is you can choose to give people access to your APIs and your applications, and you can take that access away, and it's the user that's in charge of that. All right. So that was demo number one. Actually, I'll show you a couple of other things. Just real quick here, what did I have to do to make this work as an application? So let's take a look at my banking portal with my awesome CSS skills that I demonstrated earlier. What I had to do was add dependency on Spring Security OAuth 2 client and Spring Security OAuth 2 Jose. Those are the only things that I had to add, along with, of course, Spring Security itself. And then in my application YAML, I went and specified where my authorization server is. And I also provided some configuration as to what's the ID of my application with that server. Right? So beyond configuration, you can go in and you can do more fancy things inside the code, like check what scopes the user has when you're making decisions for them, for security decisions. But we'll defer that conversation for a bit later. So point is, it's easy to do, and something you may want to consider. So if you are basically saying, okay, great, this thing called OpenID Connect, but how does it actually work? So this is the standards layer cake. So if you're looking at things and you start like looking online about all of this technology, you're going to run into JOT tokens and OAuth 2 and OpenID Connect and maybe JWS and JWE and all these different things. So what I want to do is quickly go through these standards and kind of give you like a quick tour of what they are, so that after this session, when you're dealing with your InfoSec teams, you can actually talk their language, right? And you know how to configure these standards to your needs. So the first standard we're going to look at is the JSON Web Algorithm. There are a lot of cryptographic algorithms out there that do various things. And when you exchange information with another system, you actually need to know what's the algorithm that was used. That sounds like an easy thing. So you might say, great, I used algorithm A, so I'm going to have a configuration file that says I used algorithm A. Some other person might actually call that A1 or A2. So we kind of need a standard for what are the standard algorithm names. So literally what this thing does is it's a list of names. So if you see, for example, HS256, it means something very specific. It would say, hey, this is the secure hashing algorithm with a fixed size 256-bit hash. What does that mean? It doesn't matter. The point is you know which one it is. Your InfoSec team knows which one it is. So at the heart of this is effectively, if you go to the IANA registry, you'll see a long list of what are the algorithm names, and most importantly, whether they're required, recommended, and also tells you if they're kind of become insecure and you shouldn't actually use them anymore. So you're like, okay, how would I actually use this? Well, let's look at a use case that's outside of your typical kind of OpenID Connect and login. Let's say your application deals with medical images and you actually store these medical images somewhere, like a bucket on S3, and you encrypt them. And you need to remember what encryption algorithm you actually used. So you could just go into the JWA spec and you can say, great, this is my image ID, this is the bucket I'm gonna put it in your database, and this is the algorithm that I use. So that's AAS 256. That's a known good algorithm for encryption. So knowing these standards is actually useful for situations like this. Okay? So that's the JWA. That's all there is to it. So we move on to the next standard, which is the JSON Web Key. And what is this? This is basically, again, solving the same sort of interoperability problem where two systems need to talk to each other, and it's like, hey, can I figure out what key you use? What's your public key? And there are a variety of keys. Keys tend to have an actual structure to them. So for example, if you're doing elliptic curve cryptography, they have an XY coordinate and they identify the curve. And all these details are important for the frameworks to be able to work with each other. The beauty of these standards is that it makes it possible for code written in Java to work with code written in Node, to work with code written in PHP, to work with code written in C#. Everybody's using the same underlying things. So that's what JWK is. And that kind of covers the bottom piece. The next piece up is the JSON Web Signature. Now this one is very interesting, and it's basically a way for you to know if somebody's tampered with a JSON object. Right? So you can use it to answer two questions. If somebody gives you a JSON document, you can say, okay, has anybody modified this, and who actually created this? So let's take a look at this. actually do it. Let's actually first do a demo. So I'm going to go back here. And all right, so we got, remember this guy here, the banking portal? This is a JWS token. So I'm going to take this, and I'm going to go to jwt.io, which is on the internet. Huh? I did not copy it fully, so I'll find that out in a sec. Let's see. Oh, I did. That was fine. So I took this token, and I put it onto this thing on the internet, and oh, I'm missing the E. You're right. I did not copy full it. Thank you. Hey, I shouldn't indent you guys. All right, well. Let's just refresh the page. So there we go. So this token is telling me which algorithm it's using. You can see here RS-256, which tells me that this is from the JWA, an approved algorithm, the RSA-256 with 256-bit keys. It also tells me where the keys came from. So if I go here, I can go to my UAA and I can retrieve, hello. Oh, right, not HTTPS. Okay, so this is the actual public key that was used to sign this. So if I get this right, I can go here. I can copy this certificate that was used to sign this thing, and I can put it in here. And what did I get wrong? Okay, I know what I got wrong. Just 1 second. Let's do. I probably miscopy and pasted something, so let's do it with the one where I have the JSON formatter. And paste that. There we go. So you can see it says now signature verified. So what I've actually done here is pretty cool. I've received a token, and I've been able to tell that it hasn't been tampered with by going to the server that actually issued the token, retrieving its public certificate, and using that to validate that nobody's actually tampered with this token. So this is kind of computationally efficient. I can tell that nobody's touched it and nobody's done anything bad to it on the way to me. If you look inside the token itself, you'll see here that I can see things like the name of the app, the email user, and a variety of other settings about it. So the purpose of these JWS is not to hide things from the user. It's not to protect the payload so nobody can see what's in it. It's to make sure that nobody can tamper with the payload. Right? So let's move on to back to the slides. So the reason why I'm covering this is this actually could potentially be quite useful for you outside the context of OpenID Connect and login and all this type of stuff. So the structure of it is you have a header, which is a JSON object. You have a payload, which is undefined by the spec. The JWS spec says, hey, it's whatever JSON object you want it to be, and then it has a signature. And what you do is, the reason why it looks weird is that you take the base64 URL of the header, encoding, and then you put a dot, then you do the payload, and then you do the signature. So it's pretty simple. The good thing here, like I said earlier, is it is in compact serialization form. You can actually put that token inside of HTTP headers. You can put it inside of URL parameters. It doesn't require escaping. You know, when you go and looking in your URLs and you go like %20a and all this type of stuff, and you're like, I want to decode the URL back to what it actually was before. This will make sure you don't need to do that because it's already URL safe. Anyone can decode and view it. It's easy to verify that the payload was not tampered with. And it's easy to determine who created this because you're actually verifying who created it using the public key of the thing that created the signature. Okay? So it's useful for anyone wanting to transmit or store JSON objects. So you can imagine, let's say you're in the insurance industry and you're building an application that says, somebody says, okay, my house had a flood, and they go with their cell phone and they take pictures of the damage. And then they basically upload those pictures to your servers, and they also sign on a piece of paper that, yes, this is all correct. So you may actually take all of that information and do a digital signature on all of the metadata of it, and then sign it with, and store it as a JWS inside your database. Huh? Yeah, I think we've already done the demo. Questions, comments at this point? Sorry, can you speak louder?
So the example which you gave me was a HTTP one, right? So does it work with the RabbitMQ?
Yeah, great question. Does this work with RabbitMQ? Absolutely. If it's just a string. I can take this string and I can take this string and I can put it inside of a RabbitMQ header. And the person that's receiving the RabbitMQ header would need to validate that it is correct. So the important thing to understand here about JWS is that it's a building block which you can use for many things. It is used by OpenID Connect, which is why we're kind of working our way up the stack of standards. Great question. Any other questions? All right. So if there is a technology for actually checking that the tokens have not been tampered with, is there a way for me to protect the payload so nobody can see what it is? That's exactly what JSON Web Encryption does. It again has that header which tells you what algorithm it is, the encryption key, the initialization vector, the ciphertext, and the authentication tags. It looks something like this. And you would be able to use this if you needed to, again, encrypt data and store it as in base64 URL as JSON, or send it over the network. Again, useful to anybody doing JSON with encryption. So that covers the JSON Web Signature, the JSON Web Encryption. So what is a JSON Web Token? You can kind of tell from the diagram, the answer is it's either a JSON Web Signature or a JSON Web Encrypted Token. It's one or the other. So when you hear people talking about JSON Web Tokens, it could be a signed token or an encrypted token. All right, so it does that. So it is one of the two. There's one other thing that it does, which is it offers up a standard set of header names. So people will basically want to do things like, I would like to specify who's the user that this token belongs to. Well, you could put a field in there called username, which is perfectly legitimate, but then other people wouldn't know what you mean. So if you want to use a more industry standard term, you would use the field called sub for subject, right? If you wanted to identify the token, you could have a field called identifier, or you could just use JTI, which is the unique token ID. If you want to know which server issued the token, you can put a field called server, or you can use the standard field name ISS. Issued at when the token was issued, when the token becomes valid, when it expired, and most importantly, which applications, this is the audience field, which application is this token meant for? This is a very important field to validate. I'll get into that, why that is later. But the point here is these are all optional. The JWT spec says if you would like to use them, if you don't want to, it's up to you. So how do you end up using this? When you make your HTTP requests, typically what people do is they will say authorization bearer, and then they will stick the actual JWT token right there in the header. This is likely to break your max size on your servers sometimes for the maximum length of a header, because these headers can get big. So you may have to tune those settings. So that covers that. Any questions about, and this kind of group of standards is called the JavaScript Object Signing and Encryption. And if we go back to our Spring code and our dependency, you'll see that one of the libraries that we included was, well, the OAuth2 Jose. So this is all the utility code that's for working with these types of objects. Okay. All right. So the question that was asked earlier was, well, what if I have a RabbitMQ message? There you go. You can just throw it in the header, and so long as the receiver knows that what to do with it, you're good. So what's OAuth 2 now? So OAuth 2 is a framework for asking users permission to access their data. It was invented so that people could have applications that tweeted on their behalf. That's basically what it was originally invented for. Or you build an API and you want to allow people access to it. So the concept behind it is that authorized applications get an access token that they can use to do stuff. But the problem with it is it doesn't tell you anything about who the user is. And it doesn't specify a token format. And it expects that whenever you use it, you are using extensions to it that lock down how it's configured and what's allowed and what's not allowed. So in reality, most folks end up using it as OpenID Connect, or it's OAuth plus bearer token, or it's OAuth plus some other standard that goes around to explain and to plug the holes in it. This is why they call it an authorization standard. In fact, if you actually read the document, it tells you that this specification is likely to produce a wide range of non-interoperable implementations. In addition, the specification leaves a few required components partially or fully undefined. And the framework was designed with clear expectation that future work will define prescriptive profiles and extensions necessary to achieve full web scale interoperability. This contributes to a bit of the confusion because different products and different frameworks may or may not implement certain aspects of it. So this is again why it's useful to have a little bit of familiarity with these standards. So when you're reading the documentation, you don't get lost in going like, oh, what does this mean? Well, what it means is whatever the standard says it means, right? It's not a complexity that's coming from the frameworks or the product. It's actually coming from the standard itself. So if it doesn't define what does it actually define? So what it actually defines are 4 things. They're called a resource server, a resource owner, a client, and an authorization server. How do you remember all this stuff? It's easy. Resource server, it's your web app or your API that you've built. We just call it a resource server. And that is actually supported in Spring Security 5.1. You can actually very easily build resource servers that are expecting OAuth tokens and access tokens and validate them and all that type of correct stuff. There's also the resource owner, which is typically a human being that's going to go and click the I approve this application to access my data. There's also a client. Well, a client in this case is actually not something running on your laptop. It is more often than not an actual web application on the server side, which is the web application that's going to go and read information about you from Google or check your Gmail for you. And then the authorization server it's the OpenID Connect server that's actually authorizing, issuing tokens and checking who the user's identity is. So if it does those 4 things, kind of here's the big picture flow with this. We already kind of saw this. The resource owner tries to go to the app. It goes to the application server. The application server says, I don't know who you are. I need to go ask permission to access this resource over here. So it goes to the authentication server and says, hey, authentication servers, authorization server, can you please go ask the user if it's okay if I access their data? The authorization server then will go here and say, hey user, do you want to let application 1 access your data? The user says yes. The authorization server says great, here's an access token that it hands to the client, which then turns around and is used to call the server. Now there's a lot of detail that I've omitted from this slide, and there's we're going to see them in a bunch of the slides that are coming up. The goal here is to just help to make it easier for you to remember this. And at the heart of it is just the authorization server is going to go ask the user for permission. That's all it's going to do. In order to ask the user for permission, it needs to know who the user is. So typically the authorization server also needs to somehow authenticate the user. Well, how does it authenticate the user? Well, OAuth 2 says, I don't know, it just does it. This is part of the flexibility of the protocol, right? So that's the authorization server. So here is another thing to kind of think about. that's important to know about OAuth 2 and the difference between OAuth 2 and OpenID Connect. So OAuth 2 talks about opaque access tokens. It's a little bit like your hotel key card that you have in your pocket right now. You can go, you can tap it on the door. It'll let you in into your room. But if you look at it, it has no information in it that you can easily read, right? The whole point of it isn't to say the name of the person, the room number, because if you then lose it and it's on the floor, on the street, somebody goes, oh great, hotel room, that's free. Let me go in and see what I can take from that room. The non-opaque tokens tend to be, they have information in them, like the name of the person and other fields that you can actually read. So the OAuth 2 spec expects the client applications, like this guy right here, not to even bother looking inside the token to see what's in there. It's just kind of like a hotel key card included in every request you make, and your operations will not be denied if you have one that hasn't expired. So this particular flow here, there are 4 different ways you can get this from a user to get these to make this things. So let's go through these. One of them is called the resource owner password credentials. This is what it boils down to. It basically boils down to give me an access token because I know the user's password. Because you're kind of having this conversation with the authorization server, and the authorization server wants to know, why should I give it to you? Now, this particular approach is not very secure. It's basically codifying the anti-pattern of asking users for their passwords, because you're still typing it into the application. You've probably all done this. Like, you may have a mobile app that's installed, which asks, like, say it's the actual first-party mobile app. So it's Twitter's mobile app, or Facebook's mobile app, or the bank's mobile app. Then you would expect to type your username and password in there, but if it was a different one, you'd be like, no. So generally speaking, this was seen by the designers of OAuth as a bridging mechanism for old applications to be able to not store the user's name and password in clear text to replay it, and that's why they put it in here. So please try to avoid using this, okay? The second thing is called client credential, and it basically says there is no user. I am who I say I am. I am the actual client. I actually want to access my own data rather than some other user's data. So I don't need to, you should give me a token because there is no user. It's just me. This is the equivalent of service principal that you might have for different services that you've implemented, right? This is supported in Spring Security 5.1. And so you can easily do this type of flow with that, again, by putting the correct configurations in the Spring Security settings. The implicit grant is basically says this: go ask the user if I can access their resources, but by the way, the software that I'm using can't be trusted to hold on to any secrets that you give me. So don't give me any long-lived secrets. So if you give me a token, give me one that expires really quickly, like say in like 10 or 15 minutes. So I don't accidentally, give it, or it gets lost or stolen, and somebody can use that token to get the user's details. So you don't really ever want to do this, okay? Like, don't do this. Just don't do it. Please, don't do this. But it's in the standard, and these screenshots, by the way, are actually taken from the standard itself. So the next one is the authorization code grant. And here's what you're basically saying to the user. You're saying, hey, go ask the user if I can access the resource. And by the way, I can keep my token secret. So when I ask you, when you come back to me with a token, can you give me a token that doesn't immediately expire, like maybe some slightly longer lived token, or also give me a refresh token. So when my access token expires, I can go and refresh and get a new access token so that the user does not, I don't have to bother them. The whole idea behind refresh tokens is that you don't ever send them over the wire to the application. You only send the refresh tokens to the authorization server. And because the issue with sending your access token from the client to the server, the resource server, is that the resource server can lose it. Like, it can take that token and then call somebody else with it and pretend to be that user. Apparently, stuff like this has happened in the real world. People subvert things by just using curl with somebody's access token. It's called a replay attack when you have a bearer token. So this one here, what I'd like to do is We're going to dig this a little bit more into this. This is the one that's most common. This is also supported out of the box with, since Spring Security 5.0. And so you can also very easily do this. This is what most people do when they think of OpenID Connect and OAuth. So now that we've covered that, what's in OpenID Connect? Well, OpenID Connect says, great, let's take OAuth, which is a framework, and let's lock it down even more, and let's build an authentication protocol. Because OAuth 2 doesn't give you any information about the user. OpenID Connect wants to be able to tell you who the user is that's actually logged in. So it defines a standardized identity. Like in OAuth 2, you don't have to use JWT tokens. In OpenID Connect, you have to use JWT tokens. In OAuth 2, if you were to use JWT, the JWT tokens don't have standard fields. In OpenID Connect, the JWT tokens have standard fields. So it looks something like this. If it defines what's called an ID token, which has a certain set of required fields, like who issued the token, when it was issued, when it expires, the subject and the audience, the list of apps that this token is meant for. If you actually go to the spec, you can see a lot more optional fields here. But at least they're being specific about what to expect to be in the ID token, which isn't the case with the other stuff. So let's actually see what this looks like and explore the authorization code grid. We're going to use this thing called the OpenID Connect Playground. And this will explain kind of a bit more of what happens under the hood when you have an authorization grant. So in this case, you can see that I have a URL, and this, when I hit the start button, it's actually going to go to this. So what we're specifying here is the URL of the authorization server. That's this piece here, samples.auth0.com authorized. We're specifying the client ID, and we're specifying the redirect URI, okay? Which is where, after the user gives permission, where should they be sent back so the application can be given the access token and the application can find out information about the user. And there's also scopes. So scopes in the world of OAuth are the equivalent of permissions. So this is saying, hey, when you ask the user for permission, which permissions should you ask for? Should you ask them for every permission? No. This is where you can say, hey, I'd like to be able to get their OpenID profile. I'd like to get their email, their phone number, and address. So you get to define your own scopes for your apps where you say, hey, deposit, withdraw money, pay a bill, whatever it happens to be. And then you specify what type of flow you're doing, in this case code, and a random string called state. So when you click on start, it is going to take me to the login screen of the authorization server. And it says, hey, how would you like to log in? So hey, I'm going to try logging in with GitHub. So I'll click on that, and it's going to take me to GitHub. Oh, I'm already logged in. Oh, so what happened is that I was already logged in at GitHub. So let me, yeah. So I'll do it with something where I'm not logged in. I guess I should have done this in, let's start it again in an incognito window. Because I really want to make sure you guys get these flows and how these standards come together. So I'm going to click on start here. And I'm going to say I want to go to GitHub. Now it's going to send me to GitHub's login. And typing my long password at an angle is very hard. All right, great. See, it's doing two-factor authentication. It is going to send me a code that I have to do. 08. All right, verify. So now that GitHub is satisfied with who I am, and it's done the two-factor authentication, and the application never saw these, we got to step 2, which is it got this, your code is this. I can make a request now, a post request to the token endpoint of the OAuth server and say, hey, you should give me a token because I have this code that the user has agreed for me to get an access token. And here's my client ID, here's the application that's making the request, here's the password of the application making the request. So I'll do the exchange, and it comes back with, here's your access token, and here's your ID token. You can see that in this case, the access token is like very small, and it doesn't have any information about the user. The ID token looks like a JWT token. So I could actually click next, and it says your ID token is this piece. And if I view it on JWT, you can see here that it's figured out my name and a whole bunch of other settings for GitHub. Right? And it tells me that my token is, I can click verify, and it decodes the payload. And it can do all this because it can retrieve the actual key that was used to sign that token. And that's basically OpenID Connect in a nutshell. If you're trying to figure out and you're trying to read the standards for all of these flows, there's a whole bunch of apps like this online that are like playground apps that show you how the protocol works. I encourage you to play with them. Any comments or questions? The state field is to make sure that you don't, when you get redirected back to the application, somebody could just put that redirect in a malicious website with extra nasty things in it. This makes sure that when you come back, you actually know that it came from the authorization server and not some other thing that's trying to trick you to do bad things. Does that make sense? There's a lot of details to these that are like beyond the scope of today. Again, the goal isn't to deep dive on this, it's just to give you the big picture of how all this stuff gets together. So, so that covers that. So then the next question is, but hold on a second, I still have Active Directory in my enterprise, I still have LDAP, I still have SAML, what do I do? Well, the answer is you would use an OpenID Connect bridge. And the Cloud Foundry UAA is an example of an OpenID Connect bridge. So what you do is your code understands OpenID Connect for your app, and the UAA will go and talk to the SAML server, or the UAA will go and talk to the Active Directory, or to LDAP, or to whatever it happens to be. So this is actually part of PCF. There is something called the SSO tile, if you're a PCF user, which allows you to configure plans. So you could end up with things that say, for example, a plan that says employees and a plan that says customers. So if you're deploying a microservice or an app that needs to be only usable by customers, you would go into the CF marketplace, you would select customers as the target, you would create instance, you would do bind instance. The app will then be given credentials for OAuth with the SSO server, with the UAA, and then you would do that redirect business. And when people hit your app, they would go to the login screen of your enterprise login server. So that covers the standards. I know it's kind of boring, but I hope you guys got some value in figuring out how this stuff comes together. Any questions about the standards before we move on to how can we actually use this to secure microservices? Yeah. All right, so here, so when you have an OpenID Connect server bridge, it will actually directly call the Active Directory using LDAP. So I'm putting it here, they typically have their own database, and they can talk to LDAP, and they can talk to SAML, and they can talk to everybody. So you're taking the complexity of knowing how to work with these security protocols, and you're putting it into a product so that as a developer, you don't have to deal with that complexity. So the external users, so the question was, if I have external users, where would I store them? Like, I can do this with GitHub, right, with the UAA, and the users would be stored in GitHub. Because every time you come to the UAA says, hold on a second, I'm not the one that's supposed to know who this user is. Let me actually send them to GitHub for GitHub to authorize them. Once GitHub authorizes them, it will tell me who they are. I'll take the information that GitHub tells me, and I will give it to the application. So it really is acting as a translation layer between the authentication servers that authoritatively prove who the user is and the application. Yes, so one of these, like the UAA or other products that are OpenID Connect servers, can handle an arbitrary large number of these. You can configure plans that point at OpenID, at Google, Facebook, Twitter, your internal Active Directory, a partner company's SAML, SSO, login, any number of things. Yeah. Yeah, you're welcome. Good question. Yep. You would use client credentials. I'm going to come to that, so just hold on to that question, okay? I just realized I actually have 7 minutes left, so I got to go fast. So what I'm basically saying is you should use OpenID Connect to authenticate users, but what about microservices? That's what we're here for. So the problem is microservices talk to each other, and what we'd like to be able to do is to say, hey, I would like each microservice to be able to inspect the incoming request and check to see if that request is allowed. So how do I kind of get tokens to flow back and forth between them? You wouldn't be surprised to know that when your microservices talk to each other, they are using some sort of communication protocol. So for a lot of people, we implicitly assume that it's HTTP, but it could actually be AMQP, or it could be Apache Thrift, or it could be gRPC, or it could be some custom TCP protocol or something that hasn't yet been invented. So a key idea here is there's no best protocol for how microservices talk to each other. Protocols will evolve over time, so it's good to have a security solution that can work with what's there today and what's there tomorrow. And that leads us to the question of what format should the security token be? So you can ask questions like, is the token format standard? Can the token be used with any protocol? Is it easy to parse? Can I put it in URLs? Can I put it in HTTP headers? Does it work with lots of programming languages? Do developers consider it easy to work with? And when you look at what are the standard token formats out there, you'll see that, from the 90s, there's Kerberos tickets. From the 2000s, there's SAML tokens, and there's JWT tokens. The difference about JWT tokens is they're much easier to use than Kerberos tickets or SAML tokens. So you wouldn't be surprised to basically say that, we would probably say that when one microservice calls another one, it would pass a JWT token over that it got from an authorization server, okay? So then the question is, but my application uses multiple microservices. So maybe your web app has a piece of data that comes from microservice A, a piece from B, and a piece from C. What are you going to do? Are you going to have the web browser call each one of those microservices? Most people will be like, no, I'm not going to do that. I'm going to put a gateway. I'm going to put some sort of UI gateway here, and the browser will call it, and the native mobile app will call it, and it will then coordinate access to the backend services. But that has its own problems, because when you regression test, when you change something because the browser needs a field, you have to regression test the native mobile app to make sure you didn't break it. And so people there's a pattern called the Backend For Frontend. And in this situation, if I have an iPhone mobile app, it would have an iPhone Backend For Frontend, which would coordinate access to the microservices that are the iPhone mobile app requires. And you have the browser one that would do that. So in the big picture, what we end up with is we have native mobile apps that are calling microservices, or a single page app or a desktop app, and they kind of enter through one door, but once they're through that edge, they kind of distribute into any number of other microservices inside, which introduces a problem called, how do we secure the call chain? How do we make sure that nothing bad happens as the request goes from here to here to here? When you had a monolithic app, the circle and the triangle functionality would have been in one Java virtual machine, and you wouldn't be worried about somebody accidentally curling a function and changing the state of your database. That can actually happen when you have a microservice architecture. So there's kind of two patterns for this. There's people will do this thing called the bearer token relay, whereby your backend for frontend goes to the auth server and gets a token, and then it forwards that token down the line. This is not good. It's dangerous, and it's very context dependent, so I have one piece of advice. If you're going to do this, talk to your InfoSec team and collaborate with them. Hopefully now that you know more about the security standards, you can have a more meaningful conversation about it. Like, should you never ever do this? Probably. Do you probably have to do this practically? Yes, unfortunately. The other thing that you can do is you can do what's called a token exchange, whereby you can see here the BFF first goes to the token, goes to the OAuth server and gets the green token that says who the user is, because it's an OpenID Connect server, for example. And then after that, it goes out and gets another token, the blue token, which it uses to call microservice A. Microservice A will then go to the OAuth server again and get another token, which it uses to call microservice B. So this way you don't, you're more secure. This is a better pattern than just token relay. The problem with a lot of these is that the actual RFCs and standards that describe how to do this have not been finalized. So the level of implementation is kind of all over the place. Right? There's a more advanced technique called token binding that has RFCs emerging, which secures bearer tokens. So in general, again with this, please talk to your InfoSec team about exactly how to use this. So with this one, somebody's pointing out, yes, there's extra performance hit, but you know what? I'll take a performance hit over data loss. I'm not going to go bankrupt if all my user data gets stolen, right? So you have to, this is why you want to work with your InfoSec team, because it's a trade-off decision. There isn't going to be always do this, always never do this. It's going to boil down to, when should I do this? In my specific situation, is it okay to do this, right? So that's why you want to get your information security team involved in helping you architect and design these types of solutions. Which takes us to the last part of the presentation. I'm probably going to go about 4 minutes over. I hope if you want to stay, if you need to leave, go. I think it's lunchtime. If not, please let me. Is it 12? What time do we finish? 12:30 or 12:40? Oh, I have 10 minutes. Oh, okay. I didn't need to rush through that part. All right, so the last bit is, I'm assuming you're going to be running your microservices on a platform. And so being at SpringOne, I'm assuming that platform is PCF. There are 3 features, capabilities in PCF that actually help you with securing microservices. So let's go through these. One is called route services, container-to-container networking, and container instance identity. So I just want to give you a high level, what are these things that you can expect from the platform? So route services effectively are kind of like servlet filters. You have your web browser that makes a request. It goes through the load balancer, which sends it to the Cloud Foundry router. The Cloud Foundry router says, hold on, there's a route service registered. So it sends the request over to the route service. The route service could be like an API gateway or a program that you've written to validate tokens or check that the user is authorized to do what they're supposed to do. The route service then, once it finishes its work, will send the request back to the load balancer, which will send it back to the Cloud Foundry router, which will then actually send it to the app. So if you want, for example, to do token exchange on the edge between your native mobile apps and your single page apps and turn a JSON, like an opaque token into a JOT, you can use many different API gateway products to do this, and there's a well-known way to actually install this into your PCF. So that's pattern number 1. Any questions about route services? The next one is container-to-container networking. This is one of my favorite features about applications running on Cloud Foundry. So typically when you have microservices, you're going to have like app A and app B and app C, and they're all calling each other. So in the past, I'm sure you guys love your networking team and opening tickets for firewalls, right? Who loves that? Raise your hand. Nobody, right? A lot of places I talk to say like firewall configurations might take us several weeks to actually do. So what this allows you to do is to use the CF CLI, and you can basically do things like, hey, application A is allowed to talk to application B. So you can see in this here, I've set a policy, the diagram setting a policy to say it can call B and it can call C. And on B, you can see it says allow connections from A. So it's not enough to allow the outgoing connections, you have to allow them on the other side to be received. And you can say here, deny C, which basically means do not let B talk to C. Actually, by default, anything you deploy to Cloud Foundry is not allowed to talk to anything outside of Cloud Foundry. Okay, there's a thing called security groups that prevent that from happening. These are usually configured by your platform team. You can see here too that application C will not allow B to talk to it, but it will allow A to talk to it. So the beauty of this is these things get translated down into firewall configurations effectively in your system. If you have a software-defined network like NSX, it will actually get translated into rules in the NSX distributed firewall, as an example. It also provides DNS-based discovery. So what that means, when you CF push your applications, there's an apps.internal domain. So you can find out, if you want to call B, you can say b.apps.internal for the URL of the application. Is anybody using this right now in their CF apps? Are you using container-to-container networking? Just one person? Who didn't know that you could do this on PCF? Nobody wants to admit that, okay. So the last thing, and this is the most exciting thing, is for me about PCF, is there is the container instance identity. Basically, every container that PCF creates has a certificate, a public X509 certificate, and a RSA private key that are accessible to the container. If I scale the application to 3 instances, those 3 instances of the application has 3 separate certificates, 3 separate private keys. Right? And these key pairs are rotated every 24 hours. And inside of this, when you have a certificate, it usually tells you, the name of the website, example.com, and a bunch of other stuff. So here you've got the IP address, you've got the GUID of the application, you've got the which organization on Cloud Foundry it is, what space it's in, and what application GUID it has. So basically, you have enough information to allow one microservice to call another one directly without going through the CF router and do your own mutual TLS. If you're doing mutual TLS, the beauty of it is you don't have to do anything as a developer. Because if you're doing, say I'm doing client credentials to get me a JOT token that I use to pass down the line, well, one, that's not enough because the OAuth spec says you have to use TLS to call downstream. Otherwise, anybody can steal the tokens, so you should be doing mutual SSL. So mutual SSL is going to really be helpful for the purpose of proving that app A is allowed to talk to app B. So the combination of the container-to-container networking with the policies about who can talk to who, plus doing mutual SSL authentication, you've got a good base layer upon which you can start putting on other flows from OpenID Connect and OAuth in order to start putting together a secure microservices environment. Right? As a general rule, it's always a good idea to try to push as much of the security complexity out of your application code and into the underlying platform. And Pivotal's focus on security in the platform has, you see features like this that are leading in that direction. So that is it for stuff. Spring team has asked me to say that they're hiring folks for the Spring security team. So if you'd like to work for them, take a photo and go click on that link and apply for the job. And now just open questions. Yep. So the question is, if I have a single page app, how should the single page app secure its token? The answer is, let your single page app use JSession ID. And because that's very easy. Just do your regular HTTP sessions with the app server the way you've always done it with JSession ID, and just have the SPA make an AJAX call out and retrieve the information about the user. Because it's a lot easier to locate code like that on the server side, where you have more control over it, than on the client side. So, good question. Any other questions? Yeah, go ahead. So if I understand the question, he's asking if I have multiple authentication servers, how can I configure them to trust each other, right? And so that usually involves some exchange of the public keys of each other. So one auth server could be programmed to say, when you want to check tokens issued by the other auth server, go to this URL and get the public key, or here's the public key, we've already put it for you in a directory on the file system somewhere. So that's going to be very product specific. Depends on the product that you're using. Yeah. Great question though. Any other questions? Oh, the source code is like the Hello World Spring Security 5.1, with not much modification. I would recommend you actually use the code from the Spring Security, like Joe Granja's and Josh's talk from yesterday, because they're going to explain it way better than, because I didn't cover it in detail, right? I would watch their video, and I'm sure in there they gave the link out for their GitHub repo. Great question though. Any other questions? Awesome. Thanks very much.